Hello? Can you guys hear me?
Yep.
Okay, great.
Right. Hey, everybody. So we're going to talk about SPIFFE and Spire today, a little bit deeper dive into Spire. My name is Scott Emmons, and I work for Scytale.
My name's Emiliano Bernbaum, and I also work for Scytale. So today we're just going to cover a couple of things. I mean, the main thing we're going to talk about is deploying Spire on Kubernetes. And Scott's going to give a demo showing that. So during KubeCon, we've had a couple of talks. Today, Evan and Sean Crampton had a really great talk about zero trust. The back and forth, chemistry was amazing. And then tomorrow, Evan's also giving a talk on securing multi-cloud cross clusters with SPIFFE and Spire. And then we're finishing it off with Tyler Julian and Dan Fellman talking about Uber security and how they're building a workload identity platform. So since last KubeCon, what we've really done is we went back and concentrated on getting Spire running on Kubernetes. And that's what a lot of the work that we've been doing for the last, I would say, 4 months. And some of the things that we did is we created a SATA tester. So a SATA tester is using the service account token from Kubernetes. And really, it's for versions of Kubernetes that don't have the token volume projection. And things like EKS or an older version of Kubernetes. And with the SATA tester, it gives you the ability to use the PKI in Kubernetes. You don't have to write node attestation policies that are relying on the infrastructure that you're running on. For instance, AWS security groups that you could write testers for that. And then the other thing we've done is we actually created another a tester for PSAT tokens. And that's really for versions of 112 and higher. And PSAT will give you the difference between PSAT and SAT is that you get you could rotate them, you could expire them, and you also get some stronger RBAC controls around your tokens. And Scott will demonstrate that. And the last thing we did is Kubernetes bundle notifier. So the problem we were trying to solve is how do we get the initial bundle to the agent when it tries to do its bootstrap back to the Spire server. So we actually had to create a new class of plugin for this. And the first one we did was for Kubernetes, and it basically delivers the bundle to the agent using the config map. And again, Scott is going to show that and demonstrate that. So that's really a lot of the work that we've been doing now for, like I said, the last couple of months. And all of this now is in the last version of Spire that we released, actually this week, 0.8. So another thing I want to talk about is an Istio Citadel plugin that we have right now in review. It hasn't been merged in, but it's an experimental CA module. And what we really wanted to do with Istio is have Spire be a CA plugin into Citadel. So what we're showing is off-mesh expansion off of an Istio mesh. So you could have a workload in Istio talk to a workload outside of Istio, using Spire as a bridge for that. So we're not going to do a demo of that, but if anyone's curious, we definitely will share that. I didn't put the URL for it, but it's out there. So I'm going to just go over how we do this. So what we're showing here is just an Istio deployment with two workloads. You have a task application and a task API that you want to talk to. And the task API is running outside of the Istio mesh. And what we do is we deploy a Spire server and a Spire agent outside of that mesh. And we're using our Spire CA client and the Istio node attester, right? Two pieces of code that we've written that allows the Istio node agent to go back and get a SFID from the Spire server. And there's a little setup that we have to do. First, we have to get a secret, so we have to get a bearer token out of the Kubernetes API and a bundle to basically go back and talk to the token review API. And again, this is our experimental first shot at this. So what happens is that the Envoy tries to get his SFID, and I kind of skipped over it, but the task API is already attested to the Spire agent. It's already gotten his identity, and that's been delivered to the Envoy running in the Docker container. So what the Spire, basically the Istio node agent will talk to the Spire CA plugin client, which will then communicate back to the Spire server using our node API. So that's how we could communicate back into the Spire server and send the CSR request back to Spire. And once we receive that, Spire will use the service account token and the bundle that it received to authenticate back to the token review API. And then it'll present the token that was delivered from the CA client. If that's verified, and if that's a valid token, then we will do the CSR request, and then we will deliver the SFID back to the Envoy proxy inside of the mesh. And now you could talk. The task app could now talk to the task API. And again, we ran this outside, but you could easily run the Spire server and all of that inside of the mesh, and just have a Spire agent outside of the mesh. This is all running as one trust domain, and again, this is a experimental implementation that we did, and hopefully it will be merged soon. So now I'm gonna hand it off to Scott. Scott's gonna do a little more deep dive on how do we deploy Spire and Kubernetes.
All right. Here, I'll just use the keyboard. Yep. All right, so there's a lot of considerations about deploying Spire on Kubernetes, a lot of decisions to make. So I'm just going to outline just some of the things to think about and some suggestions. You'll find that most of the time Spire server is going to be deployed as a stateful set. That's not a requirement, but it really depends on what configuration you have set up, because Spire is pretty adaptable and configurable for different environments. For Kubernetes, most likely you're going to require a persistent volume for the data dir. A volume claim template in stateful set is a really powerful way to let Kubernetes just sort of manage that volume so you don't have to provision it separately. And I'll go into a little bit more detail on that. In a production environment, Spire server requires a shared database. Currently, Postgres and MySQL are supported. And scaling out Spire servers is really fairly easy. You just need some sort of load balancer or round-robin DNS. Maybe there'll be more ways to do this in the future, but those do work today. But one thing you do need to be aware of is that the certificate store is eventually consistent. It's not synchronous. And what that means is if you bring up a brand new Spire server that's completely new, that's not using a shared file from a previous, shared volume from a previous instance, none of the agents are going to know about that server. It's not going to trust the bundle. So it takes some time for that bundle to get propagated to the existing agents so that they can trust it. And so because of that, you just need to make sure that you deploy servers and roll them out in a kind of slow and consistent manner, because you don't want to strand your agents. For deploying the agent, that's a little bit more rigid. It's always going to be a daemon set in Kubernetes. It may require local storage for the data dir. That depends really on the attester that's in use, and I'm going to go into a little bit more detail on that shortly. And then finally, we need to expose the agent workload API Unix domain socket, mouthful, into the workload. And this is, it's not tricky, but there are a couple things you want to know about. First of all, make sure that you are exposing the directory, not just the socket file. Because otherwise what happens is if the agent crashes and restarts, you're going to strand all of your workloads on that node because it's not the same file anymore. So this is kind of what the configuration looks like for that on the Spire agent. We have a volume mount with read-only false because we want the agent to be able to create that socket. And for the type, we set it to directory or create so that if that directory doesn't already exist, it will be created as a host path. For each of the workloads, this looks exactly the same except for two things. We've flipped read-only to true and type to directory. So we don't want a workload to be able to create any files in that, and we don't want the workload to be able to create the directory, right? Because you wouldn't want a rogue workload masquerading as the Spire agent. And don't worry, even though it's read-only is true, the workloads can connect to that Unix domain socket and write to it. So I mentioned node attestation and kind of how that affects potential persistence of the data dir. So there are several different node attesters that you can use. We have the ones that Emiliano mentioned that are specific to Kubernetes, the service account token and projected service account token. But even though you're running in Kubernetes, it doesn't mean you can't necessarily use the cloud provider attesters. If you're running a managed Kubernetes, your hands are going to be tied a little bit more. If you're just running on your own instances, there's generally nothing that prevents you from using the cloud provider specific attesters. But one thing you need to be aware of is you probably are going to need a local data dir. And by local data dir, I mean local to the node, right? So a host path type of storage. And the reason for that is that the cloud provider attesters, once an agent has attested, you can never attest again as that agent. You need some persistent state. And the reason for that, if you think about how an identity document works, say in AWS or Google, you don't want someone to be able to steal that identity and then masquerade as your node and then be able to register as a server. So for the Kubernetes attesters, how do we verify that the agent is who the agent says is to the server? There's two methods that are available. We can verify with a token certificate or public key, or use the token review API if you have a new enough version of Kubernetes. And the token review API is all that's available if you're running on Google Kubernetes engine, for example. Both of the attesters support either method as of 0.8. And then, as Emiliano mentioned, the new Kubernetes bundle notifier plugin. So with this plugin, we can replace both the Bootstrap certificate and the upstream CA. So the Bootstrap certificate is a static certificate that the agent uses the first time it starts up to connect to a Spire server to get the TLS handshake started. An upstream CA is an option. It's not a requirement. It's never been a requirement. It was an option where you can use another signing authority instead of just having that be a self-signed certificate. With the bundle notifier, you can kind of replace both of those just with the notifier. And what happens is that the bundle is now stored in a config map, and that's completely managed by the Spire server via Kubernetes API. So that actually is never even mounted into Spire server as a config map. It just acts, Spire server just modifies it directly through the Kubernetes API. They're versioned using Kubernetes object versioning, so we can make sure that it doesn't get corrupted that way. That config map is mounted read-only into the Spire agents, and if you are using this plugin, the Spire server data dir does need to be on a persistent volume because there's some state that's really important there. Talk a little bit about registration entries for SPIFFE, right? So you want to put some thought into how your workload nodes will be grouped. When I first started playing around with Spire, it really wasn't clear to me how do I organize my SPIFFE identities, how do I organize things so that everything gets attested, what's the difference between node attestation and workload attestation, and how do I do all of that? So I found that creating hierarchies and groupings that are kind of natural for your workload works pretty well for this. And just kind of a final note. If you find yourself creating manual entries that are using very specific node or specific information like a node UUID, that's kind of a good indicator that you might want to take a different approach. Because if you're creating manual entries on something that's like that massive thing that probably won't be around very long, it's probably not the way you want to go. Now, if you're doing automated type of registration, then this is a different situation, right? Because if you're using automated registration, it handles all of that for you. So let's just take a really simple example of 2 workloads, and we know that those workloads are going to be part of this kind of set of nodes. So the next thing we'll do is map that into our SPIFFE namespace. So we'll create something called mycluster.io nodes. That will represent all of the nodes that the workload will be running on. And then for each of the workloads, we have mycluster.io/workload/A and workload/B. So that kind of creates our hierarchy and our groupings. And then that directly translates into these registration entries. So for the nodes entry, we create a node entry. It doesn't have a parent. We specify the SPIFFE ID that we just mentioned, nodes one. And then set up a selectors for our PSAT attester, which we'll be using in the example. And similarly for the workloads, we can translate those directly in. The parent is going to be our mycluster.io nodes entry. The SPIFFE ID is going to clearly be whatever our workload is, and then we're going to have some set of selectors that are appropriate for the workload. All right.
Switcheroo, right?
Yep.
Okay,
now
so we gotta move the machine. So give us 1 second. So while we wait, what Scott's going to show us is the PSAT attester and the bundle notifier that we were talking about. So just give it 1 second. And yes, it worked.
All right.
All right.
Well, that's half of the demo right there.
Yes.
Just plugging in the
there
computer.
We go.
Whoops. There's no typo there. OK, so let's take a look at our configuration. So now that Customize is part of kubectl 1.14, I've started to use it everywhere. I think I've gotten my head around it. And so let's take a look at the customization YAML that we're going to use. So we're going to inject a config map for the Spire servers configuration and a config map for the agents configuration, and then an empty config map with absolutely no content. And this is going to be used by the bundle notifier so that Spire server will inject that bundle there. And then don't worry, I'm not going to go through every YAML file because that would be very painful. So let's take a look at the server deployment. So just in case you're not familiar with statefulsets and persistent volume claims, they're fairly new in Kubernetes. What this entry does is whenever a node or a pod for Spire server comes up, it will automatically allocate a volume. Let us take a look at the Spire server configuration. So here we are setting up all of the configuration for the PSAT attester. So we give the cluster a name, demo cluster, and then here we specify what service account and namespace is allowed or we're willing to accept agents for. And if you've looked at most of the other examples, you'll find an upstream CA here. And you'll see we've replaced that with the K8s bundle notifier, which we'll take a little closer look at here shortly. And now let's take a look at the Spire agent deployment. So the first thing to note is you saw this a few slides ago. This is setting up the socket that is used for the workload API. And here is the entry to inject the projected service account token. So you'll see that we've set it to expire after 7,200 seconds. And then, as we mentioned, we have a little bit more controls over a kind of traditional service account token, and then we can specify an audience of who that token is valid for. And then finally, we'll bring in that empty config map here. And just to kind of see where that is, so it makes more sense when we look at the configs. So we're going to mount that in at run Spire bundle. Oops, Spire config. And let's take a look at the agent config. So this entry right here, trust bundle path, again, if you look at older examples, you're going to see the bootstrap certificate here. All right, this is a certificate that Spire agent uses on its first connection to Spire server. And now we're going to use the bundle notifier for that. And then here, just as the server side had its configuration for the PSAT attester, Spire agent has its configuration as well. We just use the same cluster name, and then this is the path where that projected service account token gets injected into. All right, so let's apply this. So first, let's get this running. So this just shows that we're running in Minikube, and then it'll show our pods that are deployed in the Spire namespace as well as the default namespace. And wait for it, wait for it. Now with the bigger font, everything flows off a little bit. No, it's okay up there. Okay. Okay, so now we have a running Spire agent and server, which is great. Let us look at that config map that was empty. So you'll see now that it has kind of formatted funny. Anyway, now you can see that there's a bundle CRT in that config map. So Spire server has injected in the bundle certificate and made that available to the agents. Now, I mentioned that scaling Spire is easy. So let's do it. All right. Now we have 2 Spire servers running. Now, I'm lying a little bit. I'm not using a database. Remember earlier I said that in a production environment we need a shared database. So I haven't done that here, so let's go ahead and kill that. I want to show one thing. If you're not familiar with the way persistent volume claims work, you'll see that even though we've scaled down to only 1 instance of Spire server, there's still 2 volumes here. And with the persistent volume claims in a stateful set, if I was to scale that back up to 2 servers, it wouldn't create a new volume. It would use one of the existing volume in the ordinal number for that pod, right? Which in this case would be 1. So it's just something you need to be aware of. It's a good thing for the purposes of Spire. Okay, let us look at a client. So now we want to deploy a client workload to see that we're able to get an SVID. I'm kind of lazy here, so we're just going to use a Spire agent container, only instead of running the Spire agent, we're just going to run sleep so that we can exec into it and run some commands. So let us apply that guy. Just a little bit of typing here. Oops. Oops. I messed up. Can't see. API watch. Okay, so we're getting an error here. No identity issued. And that's really simple. This is expected because we haven't created any registration entries. Right? This workload's not allowed to run. It's not allowed to get an SVID. And in fact, we haven't even created our node entry, so our agent really isn't even attesting correctly. So let's look at what that registration entries will look like that we'll create. If you remember my earlier diagram with the tree, these are exactly those, really, one side of that tree. So we create a node entry for the cluster. We create a selector. So again, if you remember within the Spire agent and server configurations, I had demo cluster in there. So this matches that we've attested to be a member of that cluster. And then for the workload, it's very similar. We're going to have a parent which is the previous entry, the cluster nodes. We're going to give it this SPIFFE ID. And then we're going to use this selector. This is a terrible selector to use, by the way. Don't ever use this except in a demo, right? Because this is basically attesting that anything running in the default namespace or service account is attested. But it's only a demo, so it's OK. So let us run that. And in a few seconds, yay! So we've now attested the workload. So we are able to be issued an SVID, and you can see our SPIFFE ID there. That's it for the demo.
Yeah. So that's it for our presentation. So
Do you want to throw up the other slide?
yeah,
then I'll
yeah.
switch back?
Let me just throw up our URLs.
Yep.
1 second. One more Suturu. Okay, so, yep. So let's see if that comes up. Yep. So you could find all this. You could find us at GitHub. Also, our Slack our Slack is SPIFFE.io. And that's it for us. So, thank you. All Scott. That's, any questions? No questions. All right.
Wow, we answered everything.
Wow.
I find that hard to believe.
Yeah, it was good. You did a really good job. All right.
All right.
Well,
Thanks, everybody.
Thanks. And we'll post the slides later today.
Yep.
Bye.